Hello, welcome to the Petrophysics Lab. Today we're running the permeability measurement using liquid. So we're measuring the absolute permeability using the PERL 200. So here we're applying Darcy's law, where we need to get the delta P, the upper pressure, the upstream pressure, downstream pressure, and the flow rate with the flowing distance. So to run this experiment, we have the equipment right here, and we have the gas cylinder, nitrogen gas cylinder connected to it to apply pressure and push the fluid. And we'll need distilled water, 2 containers, and a measuring tube, at least 10 milliliter. So we have those ready here. And before running this experiment, we should have our sample saturated with the measuring liquid. So in this case, we're using distilled water. That means we should run Barron's method to saturate the sample before running it into this experiment and have it set in the water for overnight. So we have our sample saturated already, and we lift it in the sample. So once our sample is ready, we come to this experiment, and what we need to do is to get the rock sample, and we install it in the rubber holder right here. So we put it in there. But before that, before saturating it, we must use a caliper to get the length and the diameter, as we explained in the previous videos. So we get the diameter and the length, then we push it there. We have it exactly the same, exact size to fit. And after that, it goes inside that container. Again, we have a thinner side and a thicker side. So this is like a cone. So we put the thicker side at the bottom and the thinner to be to the top. And once we put this, also that's a cone shape, we make sure when we let it go, it goes smoothly. If it's not smoothly, like if you put it upside down, see it requires us to push, don't push. That means you put it wrongly. You take it up and you flip it and you go in easily. Once it's ready, we set it up here. Then comes the time to set up the experiment itself. So since we haven't used the equipment for a while, we see the tubes are empty. So we have to prepare the setup before running the experiment. So the first thing we need to do is to fill up our container with distilled water. Yeah. And we have the water ready on this side. Then we have 3 valves, valve 1, valve 2, valve 3, and the regulator. So the first thing is to put the regulator, to open the regulator all the way. Set valve 1 to close, set valve 2 to close, set valve 3 to close, and we have valve 4 right here. We also set it to close. This is the liquid reservoir. Once all of them are set to close, we go and we open our gas tank. So as you can see in the equipment right here, it's a maximum supply gas pressure is 25 psig. So we come here, we have the gas cylinder, we have 3 valves, the main gas cylinder, the regulator, then the valve. So we'll open the regulator all the way to make sure it's not set up higher than the 25 anti-clockwise. You may see decrease, so you want to go with decrease all the way. We close this valve and this valve. Next is we open the main cylinder valve, which is connected to that main gauge. So you see the gauge is reading about 1400, right? So this is how much pressure we have in the cylinder. Then this is the small gauge that's connected to our equipment. So we may see that it's already pressurized from before to higher than the 25 that we're targeting. So to do this, the first step is to release this extra pressure. So I open the regulator, and now I have my tube connected to the equipment. So I'll go here. There is a small button. We push it in and pull the tube. Now I have the tube open. I want to release the pressure from here. So if you can record that gauge. So since this open, the gas is not connected, I'm gonna open this small valve, and now I depleted all the pressure here. Now I'll connect it back in. I'll come here, close this again, and now I need to move the regulator to 25. This is a little hard because it's a high magnitude gauge, where this is 100. So we have 0, 20, 40, 60, not even 80. So I'll try to put it into 25. So I'll target to get it into the first dash. So you go slowly, going to increase, the regulator. All right, that's around 30. Then we open the gauge. All right, once you open, the pressure stays at how you set it. Now this is ready, so we go back to our equipment. So the first step, as I said, valve 1 closed, valve 2 closed to the top, valve 3 closed to the top. This valve is closed. Then we fill the reservoir up with water. Now it's filled up all the way. Next step, as you see here, there's a mark. Okay, I already pre-filled it, so I'll drain it, then I'll show you again how to fill it. But now what we do is we put this to fill, right? And then we open this valve slowly, right? This is to fill, this one to vent. Then we open slowly, you see the water is coming here, right? I'm gonna close this, close valve 2 again, and close valve 3. Now, before putting this on the top of sample, you see here I have air. If that air gets into the sample, then we have two-phase flow, and that will affect my measurement. So I want to deplete the air here. So I'm gonna put this in here, in this container, and I'll try to flow the water here. So how to do this is we set valve 2, 3 to flow, and 2 to flow as well. Then we open valve 1. Now once valve 1 is open, now it's all connected here, I'll start to raise, use the regulator, so go clockwise and start to increase. This measures the upstream pressure, so I start to add some pressure. To start the flow. See, as soon as I start the pressure, the fluid starts to flow and it pushes the fluid right here. All right. See, still have some gas, so that's enough. It's all right. So I'll try to do some more. But we ran out of water here, right? So what I will do is I will close valve 1, put this valve 3 shut valve 2, and then I want to fill up the reservoir. So how I do it, I put this to vent, and I put this to fill, and I open, see if it increases. I should have stopped at the mark. This mark exactly 10 milliliter. Close it, then go back, close, close. Then I want to flow to get rid of those bubbles. So I'll go flow, and then open valve 1, increase the pressure. Oops. All right, close valve 1. Now I get rid of all the bubbles here, and it's saturated. So I'll put this on the top of my sample right here. Then you have to be a little careful, so I'm gonna take this up first, and then put the lid, and there's a groove for the screw, so you keep screwing. I'll screw this in. Right, then I'll use the top one. You need to tighten it. It's tight. Now I'll use the small one, tighten it a little more to avoid any leakage. All right, so now we have the fluid go inlet from the top, outlet from the bottom, and we collect the liquid from here. So the whole idea here is we want to measure how long it takes to collect 10 milliliter of water, which is how much we have here. It goes from that top mark to this lower mark. So now we'll run the experiment. So again, I'll open the regulator anti-clockwise. The valve 1 is closed, valve 2 is closed, valve 3 is closed. My reservoir is closed. And then I will fill up the reservoir here all the way. Then I need, second step is to fill up this reservoir with 10 milliliter. So to do this, valve 2, set it to vent. Valve 3, set it to fill. And open this slowly and keep your eye on the container. So you go slowly, slowly. Once it hit the line, I will stop, slow it down a little more. All right, that's done. Now it's ready. So the next step is I need to start the flow and I collect the fluid from here. So I have the container here and valve 2, I'll set it up, I'll close it and I will close valve 3 and I will open. Before opening valve 1, I'll try to set the pressure a little higher. So I go clockwise. And let's try to apply, let's say, oh, that's high. Let's try to target about 2 psi's. We don't want to run fast, so no, 3. Let's try to target this. And now I'm going to leave it to stabilize. Once it stabilizes, I'm going to write it down in my data sheet. It's down. It's very sensitive. Okay, let's try to stabilize it at a higher pressure. Now let's see. And since those valves are closed, you may open valve 1 as well. It shouldn't affect it. Let's see if this will help with the stabilization. So now I put valve 1 open, and while I'm waiting for the regulator to stabilize. Straight. You make sure you don't have any leaks. I'll try to limit a little boost. Let me try target a higher pressure. Check the gauges. Make sure that the gauges are set correctly. This is open. This is connected. This is open. All right. Start to stabilize. It takes some time. All right, now 890. This is what we have. I think it will stabilize around 8.6 or 8.7. This requires some patience. I think you may pause until we get the step. All right, so as we were waiting for the pressure to stabilize, so now it's stabilized at 7.68. So I'm gonna type down 7.68 as my upstream pressure. And next, we have the valve open from before, and the regulator is set. So we'll set valve 2 to flow, and we'll set valve 3 to flow as well. Once we do this, you start to see the fluid will flow through the sample, and we use this container and to wait for the fluid to come out from here. And we want to see how long it will take for the 10 milliliter to come out. So once we put valve 3 to flow, we run the stopwatch to calculate how long it would take for this 10 milliliter to kick in and come out here. So now I think we'll pause and we'll wait until the fluid comes out there. All right, so the fluid is coming out. As I said, we have our stopwatch, and as a recommendation, we recommend this experiment to be run at 20 psi, not at low pressure. Now we get the flow rate. We wait until we collect the 10 milliliter. Okay. Now, as if you noticed when we start the experiment, that tube was not filled up with water. So to do it properly and measure it correctly, we're going to repeat it. Now we make sure that we have all the tubing filled up with water. So I'm going to stop it. I'm going to put valve 3 to close, valve 2 to close, right? And now I'll wait until this water to stop flow. Right. So now we have our setup ready. I'm going to empty this. Now, we don't have any air gaps in the system. It's all connected. It's ready to go to get the correct experiment. So we're going to run it at 25 psi. So we'll repeat all the steps. I'm going to close valve 1, valve 2, valve 3, valve 4, and we'll fill up the reservoir. Then, as we mentioned before, we want to fill up those 10 milliliter. So to do this, we put 2 at vent and we put 3 at fill. And then we open this small tube. You see the fluid rises. We'll wait until it hits 10 milli. We need a little more. All right, now we're good. And now as you see, our experiment and all the tubing are filled up with water. So once we start the flow, things will flow smoothly. So I'll close valve 2, close valve 3, regulator. I'm going to open it all the way. Right, no pressure. Then open valve 1. And we said we'll apply a pressure of 20. We'll target 20 psi. All right, we'll wait until it stabilizes. All right, stabilized around 1950. Once it stabilizes, V2, go to flow. V3, go to, you see the pressure also still stabilizing. Now 19 psi, 3 to flow, and I put on my stopwatch. So I have it there, and you see I get the flow. So this is the correct measurement because we don't have any air throughout the system, and our calculation is correct. So we track pressure, and it's always good while you're collecting the fluid to keep your eye on the pressure gauge. If you see any fluctuation, it's better to keep recording those pressure fluctuations. And at the end, when you do the calculation, you get the average pressure during the experiment. So we keep this running until we get the 10 milliliter. And once we have that, we get enough data to measure the permeability, as we have the upstream pressure, downstream pressure. As you see, it's open to the atmosphere. So it's 0 psi-G or 1 atm or 14.7 psi-A. Yeah, so since this is psi-G, so we use 0. So this is the pressure upstream, and also it's delta P. You need this. You have the length of the sample, and you have the diameter to get the cross-sectional area, and you have the fluid viscosity. This is water, and you get delta P. So you'll be able, and by collecting these fluid with the time, so let's say we collected the 10 milliliter in 5 minutes. So then we divide 10 milliliter by 5 minutes, and that will give us the flow rate. Right? So it's 2 milliliter per minute. And now we have the flow rate, diameter, length, viscosity. You'll be able to measure the permeability. The absolute permeability, because we are flowing only one fluid, which is water. And once we finish the experiment, we collect all the data. We put the valve to V2 to close, V3 to close, and V1 to close. And then we have our collected fluids. Make sure to close the regulator by turning it anti-clockwise, and then open valve 1 to release any pressure. Then close it, everything is closed, it's set. In that case, we come here and we close the small valve, close the cylinder valve, and we may leave the regulator as is because we set it to 25 already. Thank you.